The solubility of ionic compounds. So it says here ionic compounds can either be soluble or insoluble in water. So even the insoluble ones, you just need to remember, are still soluble, but to a certain extent, which was what we said, less than 5%. So the question is, sometimes I'm asked this question, is there anything in between 100% and less than 5%? And the answer is no, at least at this level. So again, we will treat things as insoluble and soluble. Sometimes they can be sparingly soluble. What we need to do here is practice how to tell whether a compound is soluble or insoluble. And we have to use the solubility table. So it's available on your LMS, meaning it's available under the handouts. It's called the solubility table. Here is an example. Let's start. Let's practice some. We need to tell whether each is a soluble compound or not. It's very easy to use this table, and it will be given to you on the test. No need to memorize. However, sometimes you have to know parts of this table for Gen Chem 2. Memorize parts of it. So let's go to the solubility table right here. You might have used this before. If not, it's very, very easy to use. You have two tables within this solubility table. You have compounds that are soluble compounds, and you have what we call insoluble compounds. Basically, what does that say? It says here that any compound that contains these anions, negatively charged ions, are soluble except if they're combined with some of these elements. On the other hand, down here, all of these compounds that contains these ions, like sulfide, carbonate, etc., are insoluble unless they contain these elements, these cations. So this makes these soluble. This makes these insoluble. That's how you should think about it. So we have KBr. I'm going to write it down here. Let's start. So what's in K? What's in KBr is you have a Br. So again, this is listed by the ions. So we have KBr. Right away, we split this into the K plus and the Br minus. Or we can just simply look right there. I mean, the charge is given right there. So this tells me that KBr should be soluble. However, let me see if K is one of the exceptions here. Let me see if K is one of the exception, K plus, potassium ion. So I go and I look here, I don't see it, so therefore it is soluble. If you look at, let's go back to our lecture notes. So again, we said this was soluble. So if it's soluble, is that a strong or weak electrolyte? Yes, it's a strong electrolyte. Let's do PBBr2. So you have PB. You can tell that the charge is a +2, and then you have a Br, you have a -1. Once again, we're going to go back to this sheet and determine if PbBr2 is soluble. So again, it's Br, so it should be soluble. However, is Pb one of the exceptions? Yes, right here. It's right there. So that makes it insoluble. That makes it insoluble. Again, Pb is an exception. So this is insoluble. So this is an exception. Okay, let's do CaSO4. Ca is a +2, SO4 is a -2. By the way, this is a weak electrolyte. Let's go back and see. SO4 should be soluble, but is Ca2 plus one of the exceptions? So we start looking no, 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 and no. So again, it's not one of the exceptions, so it should be soluble. So it's a strong electrolyte. Now let's go to the next one. Now this one uses the other table. So I'm going to write it down here. Of course, we can transfer that, but because we would like to see how to use this table. So we have FePO4. So you can split this into Fe and PO4. You know the charge of PO4 from your nomenclature ion sheet. That's a -3, so this must be a +3. But nevertheless, here it is. It's given to you. Well, it says these compounds that contain PO4 phosphate should be insoluble. But let's see if Fe is one of the exceptions. Fe. So it's not ammonium and it's not one of the alkali metals. So be aware what the alkali metals are. This is group 1. Group 1 is lithium, sodium, potassium, etc. So it's not one of the exceptions. Therefore, it is insoluble. So this is insoluble, which means it's a weak electrolyte. Let's see Na3PO4. That's Na plus, and of course, it's still PO4 minus 3. Let's see. PO4 should be insoluble. We just talked about it. But let's see if Na is one of these. It's not ammonium, but is it one of the alkali metal cations? Yes, it's in group 1. So therefore, it should be soluble. Use a different color here. So this is an alkali. Metal, so it should be soluble. So it's a strong electrolyte. You can work on CaCO3. Let's see if it's, what do you think about that? CO3 is down here. It's insoluble, but is Ca one of the exceptions? It's not NH4. And is it one of the alkali metal cations? Is Ca in group 1? Look at your periodic table. You will not find it there. So therefore, it remains insoluble. And that's why we said chalk or limestone is insoluble. So in this case, is insoluble. So it's a weak electrolyte. Become good at this. You will need to know this very well. I mean, it's really, really straightforward. Usually there's no issue with students understanding this, because you need this for the next topic right here.